Alright, so in this video, I'm going to be doing something a little bit crazy. Alright, so in this video I'm going to be backfeeding a 277 to 120 volt step-down transformer in order to get 277 volt out of 120. So transformers, what they do is they work off of mutual inductance. So let's say we take a 277 volt secondary and we introduce that alternating potential difference here. Now a magnetic flux is going to form between those two windings. Now in order to figure out what your turn ratio is, just you take your primary voltage and you divide it by your secondary voltage, which in this case this gives us 2.3. So what that means is we have, for every one winding on this secondary side, we have 2.3 windings pretty much in our primary side. So our voltage induced on the secondary is going to be this number divided by 2.3, which we get 120 out of. But see, what I'm going to be doing is, instead of feeding it from this primary side where we have, all of these shit tons of windings, I'm going to introduce it here. So pretty much now, instead of dividing this number by 2.3 and getting 120, we do the reverse. And now what we're going to do is we're going to multiply 120 times 2.3, which will give us 277 volt. Inductance is going to happen the same exact way, no matter where I choose to feed it. Now, my educated guess is that I'll still achieve this 277 volt through the inductance, because I'm still giving it one of its designed voltages. So let's try this out and see if we achieve the desired result. Alright, so this is the 277 to 120 transformer. Here's our here's our 277 volt wire off of this transformer. It has three wires pretty much. It's got a black, a white, and then it's got this orange for the 277 volt lead. It's got a black for your 120, which really you'd hook up second, but now we're introducing 120 to it to achieve this, and they both share a neutral. So pretty much what I'm going to do is I'm going to turn it on, and I'm going to get my meter on it to see what we don't read off of this. All right, we're on. All right, so we're set to volts AC. So here's our 120 coming in. So we got 123 volts. That's on our black and our white. Now for the moment of truth, to the orange lead, 272. I'm pretty sure that's not even less than 3% of what 277 is. So it's safe to say that we still achieved our desired voltage range out of this. That's pretty damn cool. Alright, so now for the interesting experimental side of this, what I'm going to do is I'm going to feed the 120 volt onto the primary side where the 277 volt's supposed to go. So now I'm feeding it up here where we have 2.3 times the amount of windings here than on the secondary side. So knowing that my turn ratio in this particular transformer is pretty much 2.3 to 1, my educated guess is that if I divide this by 120, or if I divide 2.3 from 120, I did the math earlier, I get 52 volts, which is a pretty irrelevant voltage, but just to show how inductance works and all of that, and to show the turn ratio relationships, I'm going to take the educated guess we're going to get 52 volts. So what I'm going to do is I'm going to swap the leads and we're going to test it out. We're back to volts AC. So now got 120 across our what is the primary now. So now let's see what we get here. 54 volts. 53 volts. Yeah, so my guess was once again pretty spot on almost. So there you go.